In this lecture we're going to talk about functional skills and what the motor control researchers have found out in regards to those skills. The skills will be about upper body and lower body. First, let's have a look at the rapid aiming task. For the common sense, there's a speed accuracy trade-off in manual aiming skills. What it means is that if you're aiming the small object, your speed of reaching for the object will be slower. So ergonomically, the people have developed the machine according to those speed accuracy trade-off. For example, if you go to Fitness First and do the treadmill, you will see this large stop button facing towards you. So if you're like in an accident, you have to press the stop button as fast as you can. It has to be big, because if your speed goes up, your inaccuracy increases also. The other example would be those little buttons. Usually reset button is small compared to the other buttons. One of the reasons could be if you want to reset and you have to aim for the reset button slower because it's small, and you'll have more time thinking about, oh, should I have to reset or not? So you increase the time by aiming for the smaller object. So we can fill those blanks now. We slow down when we wish to ensure the accuracy of the movement. And when we move more rapidly, we become more inaccurate in terms of a goal. This speed accuracy trade-off can be expressed in mathematical terms, and it's known as Fitts law. There's not many laws around in motor control area, and this is one of the famous law. And what law does is that when you put the variables in, it can predict the outcomes associated with that variable. So outcome can be predicted when certain variables are involved. So the setting was like this. I will show you in bigger version. So the black box is the target, those two boxes, and what the subject had to do was move as fast as he could in 15 seconds. So in 15 seconds, the stylus with the stylus, the subject moved back and forward as fast as he could, without going over or inside the target, outside the target. So when the Fitts did this one, what he found out was there was a mathematical relations to the variables. Well, this is the expression, and you can say, oh, what the heck, but don't worry about it. What you have to do is understand that equation in words. So in this one, A means amplitude of movement, and W means width of the target, and MT means average movement time. So with the example, A in this case is 4, well it's arbitrary, let's say 4 centimeter for this one. So the distance between the center of the target is the amplitude of movement. Width of the target is simply the width of the target wall. So this case is 2 centimeter. So if we know this amplitude, which is 4 centimeter, and the width of the target, which is 2 centimeter, we can predict the average movement time taken for 15 seconds. So if we plot those relations into a graph, you will see this linear relationship between the log base to the base of 2 with this equation, amplitude and width. If you put amplitude and width into that equation, you can predict the actual average movement time. So let's say log base of 2 of 2a over w was 4. You can predict the movement time as, or it will take 0.4 seconds.